Oh, hello there. My name's Kyle Birch. Today, we're going to be talking about black holes. I would say let's hop on the magic school bus, but I don't have the budget for that. So instead, let's hop on the magic drift trike. Let's go!
Whoa! That was crazy! But now that we're here in space, I can show you this black hole. Now, black holes are super dense pockets of mass that get compacted into an incredibly tight space. Typically, they form when supermassive stars collapse in on themselves. The pressure of the star's thermal fusion can't compete with the gravity of that much mass being pulled in on itself, right? So what happens is the star collapses, and all of that mass is all of a sudden an incredibly tight volume as opposed to the large volume that used to be the star. Alright, now the reason we call them black holes is because they absorb all the light that gets near them. Now, because there's so much mass packed into such a small space, the black hole has incredibly strong gravity, that literally anything that gets near it can't escape. And we call this area around the black hole where nothing can escape the event horizon. Anything that enters the event horizon, it's doomed. It will now get sucked into the black hole because nothing has a fast enough escape velocity to escape that gravity, not even light. Now, you might have noticed this disk around the black hole. I really hope I'm pointing towards it somewhere. That is called an accretion disk. Now, that's a collection of dust and gas and just all sorts of matter that the black hole is absorbing. But because it's being drawn in slowly, it starts to rotate around the black hole, creating a disk that's emitting light and radiation that we can see. Now, because black holes absorb all the light around them, we can't actually see what they look like. But these disks give us a pretty good representation of where they are, how big they are, and just all around give us the chance to actually observe them, at least in some form. This is what most pictures look like because all you can see is the little disk, and the actual black hole is just nothing because the light can't escape it, so we don't know what it looks like. Now, you might be wondering, what happens if I get too close to a black hole? Now, sadly, I don't want to throw myself into one, so today we have this rainbow ball that my parents happen to have as a stand-in. So basically what happens if you get too close... Okay, not actually. I just thought that would be funny. Although the process is called spaghettification. Alright, now imagine with me for a second that this still PNG of myself is like a piece of slime. When you take a piece of slime, you pull on either end of it, it gets incredibly thin. And the same thing happens when matter enters the event horizon of a black hole. Now, in the case of this PNG of myself, the part of him closest to the black hole is going to be affected by its gravity first. So it's going to start getting stretched immediately, while the other part of my body isn't. Similar to a piece of slime, when you pull on one end, only part of it starts to stretch.